on a geospatial data, especially when you're analyzing it, a very good understanding of the kind of format your data in is very paramount. So this will decide how you're going to interact with it. For example, Shapefile is one of the most commonly used vector formats. Usually it is very lightweight. It is lightweight because it doesn't take a lot of space, most shapefiles, compared to if the data is in, for example, CSV format or GeoJSON, in CSV format, or geo packages. So Shapefile is most commonly used because it is lightweight and it doesn't have a lot of it doesn't have a problem when it comes to file size, and it is usually used. And then we have GeoPackage, where you can have multiple vector layers, raster layers, different type of layers of your data in one single file. So GeoPackage is used. And also GeoJSON. So GeoJSON is usually used for web applications. It is actually a very go-to format because your spatial data will be represented in JSON format, which can easily be manipulated and worked on. And also CSV. So CSV is more or less like a very common data format that we also work with. Also, CSV is also a commonly used spatial data format, especially in geospatial data analysis. And also for the raster data, we have the GeoTIFF, and then we have the image. That's the headers image. So why are we using Python? Why are we using Python for geospatial data analysis? Python is a powerful ecosystem. It has a lot of libraries. I'm talking about a lot of libraries. If you are thinking about numerical operations, if you are thinking about visualization, Python offers a library of that because it is very powerful, especially in the data space. And also, it is open source and cost effective. Python is easy to use. Anybody can pick up Python compared to other geospatial tools that are available. And also, Python is usually preferred because it's able to, you can use it for automation. You can use it to write automated, you can use it to carry out, the code can be used to automate tasks. And it is very scalable too. And you can handle large data sets using Python. Also, Python is very good because now for most GIS software, there's usually a counter, there's usually a part of it that has a Python kind of like environment. For example, for QGIS, we have PyQGIS. So that means that you can write Python scripts and run it in QGIS. And also Python has been used for most geospatial applications, especially web applications that we see now. Most of them are powered by Python because it is very versatile. If you are talking about air quality monitoring, Python is used to write those code and show those kind of visualization and analysis, to run those analysis. So now that we've talked about Python, let's go to Python environments. Okay, where can we write Python? So usually in geospatial data analysis, there are a lot of environments that we can use, but these are the major ones. You can write your Python code in Jupyter Notebook. That means that you can, most code editors, Code ID, for example, VS Code, they all have a Jupyter Notebook extension whereby you can write it. So you can write your Python code there. And also you can write it on Google Colab, which is like a cloud-based for spatial analysis. So there is free access to a lot of, if you want to do kind of like an heavy work, or if you're working with a lot of heavy data in your analysis, Google Colab is actually very good, especially if you don't have a laptop that has a lot of high specification. You can actually opt for a cloud-based, which Google Colab is fantastic at, and which we'll be using in our hands-on, because we are going to be having an hands-on and interacting with Python libraries that are being used whenever we're doing geospatial analysis. And also you can use Python in QGIS that I mentioned earlier, PyQGIS. I can also use it in ArcGIS Pro. So the red sign just means that this are the disadvantage of running it in each of the environments. So Python libraries. So there are a lot of Python libraries that are available, but these are kind of like the topmost key libraries, personally, that I myself work with on a day-to-day whenever I'm analyzing geospatial data or I'm carrying out spatial data analysis. GeoPandas is more or less like the, how do I put it now? So we have pandas, as you all know, in your normal data analysis and data science. But in geospatial data analysis, we have GeoPandas. So that means that pandas, I should call it pandas on steroids, pandas that can handle geospatial tasks. So we call them GeoPandas because they can handle all manipulation, data manipulation that has to do with spatial data. And we have Rasterio. So when you are handling raster data, so usually GeoPandas are used to handle vector data. And we talked about how we have different vector data formats like Shapefiles and GeoJSON. So for raster data, you use Rasterio to handle the raster data. Time will permit us to look at, to explore Rasterio. So we'll just focus on handling vector data in this session. And also we have Shapely. So Shapely is a Python library that we use for geometry operations. So most of the time, we talked about vector data coming in the form of lines, polygons, and polygons, right? And points. So a representation of this actually needs a library that can actually plot this geometry, because points, lines, and polygons, they are geometry. So if you put 3 lines together, it makes a triangle. So that's a geometry. So Shapely allows us to do a lot of geometric calculations, geometry operations. So for Folium is a go-to for geospatial data analysis. If you are using interactive mapping, where you'll be able to zoom into your map and kind of like understand the data better. So Folium is used for data visualization. Also, Matplotlib and Seaborn is also used in geospatial data analysis, like the normal data analysis that we do. We have scikit-learn if you are considering building a model around your geospatial data. We have the Open Route service, which is open source, and we have the Cortestly. So Cortestly is more or less like static maps. If you want maps that does not move, that is not interactive, you can consider Cortestly. And also Matplotlib also is very good for static maps. If you want to plot maps that are static, just to show the representation. And all this will be seen in our hands-on. All right, so for spatial analysis, so there are a lot of few techniques like that we can explore when we are carrying out spatial analysis. So buffer analysis is a technique that can help us kind of like understand area of influence. For example, if we are to know, let me give an example. If we are to identify population or communities that falls within a particular distance, we call that area a buffer. For example, if you have an hospital now, a buffer means you want to kind of like you want to know the area that hospital covers within a 5-kilometer radius. So, and the aim is just to help you visualize if there's an overlap. So, for example, if there's an overlap between 2 hospitals, that means that there's a lot of hospitals in that area. So that means that it will not make sense to have another hospital within that 5-kilometer radius, and this actually helps planning. And this insight can only be gotten if you do your geospatial analysis. And for spatial join is also a technique that helps you kind of like join 2 spatial layers together, and then you can actually get a lot of insights and relationship from 2 different spatial layers, and to use it to identify features too. And then we have the points in polygon analysis, which determines which point falls within a given polygon, or which if a factory is within a particular polygon, does that mean that the analysis just shows that this facility falls under this particular local government, and within that local government we can say this facility falls under this ward. this point in polygon analysis helps us understand that better. And then we have distance calculation, whereby we can find the distance between each point. So we can, from our data, we can calculate and even map it on our map using Python libraries, the nearest point location of different features that we have in our data. So a good example is a business. We want to know the distance between one business to another. We knowing the distance between one business to another kind of like informs us, okay, is there monopoly? Is the competition high? So if the distance between a business to another business is low, that means there will be a lot of competition. And insights like this actually help businesses cite maybe their next facility or next business space that they want to set up a business, so that they will reduce competition and they can actually optimize the location that they are. So leveraging on all these insights, Python libraries provides, it's a powerful tool. Let me just put it's a powerful tool that can help us achieve all this aim. So we're going to move on to the hands-on session, and I'm going to be taking you step by step through how we're going to be handling the data, and we're going to be analyzing it using Python libraries. So all we're going to be doing in this session is how we'll be using, so we're going to see how we'll be using different Python libraries that are available in geospatial data analysis. So I'm going to stop sharing my screen for now and then switch to our code. So to get feedback from the class, hope you've gained one or two before we move on to the hands-on session.
Yes, I've gained a lot. I just want to ask, can we follow along as we progress to the Google Colab? Like what you are doing, we are also doing it on our system. Is that possible?
Yeah, that's fine. I will really appreciate that, and I will try as much as possible to be to kind of like pull everyone along. So I'll be showing you step by step how I got the data, and so even if you go back to the recording, it will be easier to follow. Is that okay?
All right, thank you. Thank you very much. It's okay.
Okay. Can you hear me? Hello, can you hear me?
All right. So while I
Hello,
was
can you hear
for Godwin to put everything together so that we can jump on our hands on. All right. So once again, so this is Data Science Nigeria, and I've talked about geospatial group where you can not just learn like this, but collaborate with other people, other professionals. People that are there on the group are not just maybe they are just there to come and learn. No, we have a lot of professional people already. Like they are doing well already in what they are doing, and you can have. Then there is opportunity for mentorship. So there's several, and the one thing about any group under Data Science Nigeria, you get first-hand information, you get first-hand opportunity. Anything we are looking for, if we have anything in mind to offer the public, I tell you that our community members are always the first to be considered. There are a lot of opportunities coming but during May, we start preparing for our data, our boot camp, and the things you get first-hand information on some of these things. So I enjoy you. If you have not been following or you have not taken it so seriously, we are bent on helping you to achieve that goal. That's why we are here. To make sure that you also get to that place you want to get to. So I'll just leave the way now so that we can get on our practical class. Thank you so much. How about you, Godwin?
Okay.
Yeah.
Sorry, I want to ask a question. Can you
my file so that it will be easier. So the data that we are going to be working with is grid tree data. So we're going to be getting some local government boundary data of Nigeria, and we're also going to be getting some data on health facilities in Nigeria. So the objective of this demo is just to show you how you can actually interact and work with, leverage Python libraries to do some basic analysis. It's not an in-depth demo, but it will kind of like introduce you to the world of using Python. And from experience, Python is quite easy to use. With practice, you are going to enjoy using it. So if you are with me, you can just go over to data.gridtree.org. I'm sure you can see my screen. And we're going to be downloading some data. So let me look for. So we're going to be downloading some data from boundaries. So you can just search for the data on Nigeria. Let me change the location. And if you want to practice, you can come over to Gridtree to get geospatial data about Nigeria, especially Nigeria operational LGA. Yeah. So I'll be fast because of our time, so I can really take us through it. So while this is loading, we're going to pip install some libraries in our Google Colab. So I'm sure you are aware how to get your Google Colab. You just type Google Colab, and then you can create a new notebook. It is free. You can create a new notebook, just as I did. So you have something like this. So while we're waiting for that, let's go. First thing first is to install this geospatial library. So we're going to be installing GeoPandas, we're going to be installing Shapefiles, we're going to be installing Folium, Rasterio, Fiona, and Contestly. So it's still loading. Yeah, so we have the Gridtree Nigeria operational LGA boundary. So this data contains the boundaries of all local governments in Nigeria. So you have something like this. So you click on download, and then you see different formats. You see it in CSV, you see it in Shapefile, you see it in GeoJSON, you see it in KML. This shows that it's a vector data, like it contains vector data. And then you click on the shapefile. So once you click on the shapefile, it's going to download. Okay. Our Google Colab has opened, so you can just start the whole process, just as I've showed you. So the file is going to download as a zip file. So it is very important that you unzip it. So once you unzip it, you are going to find a lot of, okay, I'm going to show you. So once you unzip it, you're going to find you're going to find close to like six data right inside that folder after unzipping it. So you're going to see grid tree, NGA, operational LGA boundaries. You're going to see 6 files if you downloaded the shapefile. So once you've unzipped the file, and then you have the files. So after installing your libraries, you import the GeoPandas as GPD, you import Folium, you import Rasterio for raster data processing, even though we'll not be using that. Then you import Shapely.geometry, that's for our spatial operations. And then you import Matplotlib as PLT. So let me just add some to it. Import pandas as PD, import NumPy. Normal libraries that we're doing import as NP. So I'm sure you've done this. You load this, and then you load this. So now you now go to the files. So this is going to show where to upload the file. So because we are working on Colab for this demo, you can just upload. You can upload it right from your so you're going to see something like this. So the folder that you unzipped it to, you go to it, and then you copy all. So most files, especially shape files that you download in zip file, actually contain all these documents. And it is very important that you import all. We can see the SHP file right here, but it's important that you import all whenever you are working with the data. So open it. You opening it, it now loads into the Colab environment. So that means that whenever you call on the data right in the environment, you'll be able to access it. So you look for the shape. Yeah, this is the shape. And then you copy it. You copy the parts, and then you do this. You copy it, and then you do this. And then you run it. Yeah, I hope it is clear. I hope it is clear. I'd like to hear response.
Yeah.
Am I going too fast? Am I going too slow? Do you need clarification?
Yes. Hello, sir, can you hear me? Hello.
All right. So I'll just go ahead. I just want to bring you guys so that you will follow it step by step. Okay. So after doing that, the next thing is to check the CRS. So the CRS is the coordinate reference system, and it's very important to check the coordinate reference system of your geospatial data. So GDF is what we have assigned the data to be as GDF. So GDF is this geodata frame, and when we call it, the EPSD is 4326, which is the correct CRS for that data. And then we check the info. Then we have this feature. So one of the ways, so whenever you are given a geospatial data, it is very important, even before you do a lot of complex visualizations, you can just try and visualize it using matplotlib.pyplot. You have something like this. Just from this simple code, you are able to visualize all the local government boundaries in Nigeria because the data contains all of them, of all the local government boundaries in Nigeria. You are able to visualize it like this using Matplotlib. So Matplotlib can also be used for data visualization, and it helps you understand the data better and see the visualization. Also, we mentioned something about Folium being used for interactive mapping. And if we run this code, we'll be able to see, we can zoom out, we can zoom out, we can zoom out, and we can zoom in. So these icons just shows each local government in Nigeria. So when you click on this, you can see this is Gombe. When you click on this, this is Toto. When you click on this, this is Ijebu East. When you click on this is Ezeagu. So Python is a very dynamic. You get a lot of very good visuals using Python libraries, especially if you want to communicate your information using geospatial data. So let's move on. So let's try to filter individual states. So just like the normal operations of pandas where you can filter things, you can also do the same. So GDF is more or less like geodata frame, which we've actually assigned to our data. And we are featuring for Kogi. We're trying to see, okay, can we get the map of Kogi right from our data? So we are featuring for Kogi. And then Kogi DDF is a data frame that contains only Kogi. And then we tried to plot just Kogi local government. And then we get this. We get this. We get this visualization. And you can see the legend that has, so this is, okay, based on the column, this is Yagba West, this is Ogori, this is Ampa, different colors just to represent it. And if you don't want the legend, you can just comment it out. Let's give an error. You can just comment it out. Okay. So we have Kogi without the legend. So this is a map of Kogi, and this is done using matplotlib, which is also a very good Python library. Also, we want to do the same that we did for Kogi, but we want to use Folium so that we have a very interactive map to see the different local governments just in Kogi. And then we see this. So you see Yagba West, Yagba East. And the interesting thing about Folium is that you can save this as an HTML file. And that means that you can actually host this on a website where you can actually see it. And most people that use geospatial, that uses Python library for geospatial data analysis, actually leverage it, especially to host when they want to kind of like integrate their map into a web. So you can use Python libraries to do this. And you can zoom in. You can zoom in right to the details. So that's one of the benefits of using Python libraries for geospatial analysis, especially the visuals. So this is us featuring for multiple states. So from what we are seeing now, we can see that a lot of operations that we use pandas for, GeoPandas can also do that. For example, like featuring, and also matplotlib can also do that. So we can see the different, the map visualization for Southwest showing the local government boundaries. Also, I mentioned about Cortesly. Cortesly is it is used as a Python library that is very good for static maps. So if we are to map this using Cortesly, we'll have something like this. The Southwest is not defined, so let's run this code first, and then let's run this. So we have something like this. So this is just like a normal mapping of different local government boundaries. And geospatial data analysis so right now we have the map, and then if we are able to bring in attributes or attribute data as they call it, for example, mapping out health facilities, down to the ward, down to the settlement, down to the street, we can actually get a lot of insights to, okay, what is the coverage of a particular hospital in an area? What is the distance between them? If we are to cite a new hospital, this is just an example in terms of the application in health. If we are to cite a new health facility, can we see where the already existing health facility is? And then we can say that, okay, based on what the representation of this geospatial data, okay, it would be for the best outcome if we cite it in this particular area because it has low coverage. All these insights are gotten and made easier when you had location. It gives it a lot of context. And with the use of Python libraries, you can actually see it and better communicate it. So Earth facilities. So the next thing that we're going to do now is we're still going to import data. So before we go ahead, the goal now is, now that we've mapped out the boundaries of all local governments in Nigeria, is there a way we can take a data and merge it together, an ordinary data, and merge it with what we have so that whenever you're seeing the map, you can actually see the representation of the features in that boundary. So you can know where for example, you can know where a particular school is. You can know where a particular hospital is. You can know where a particular facility or a particular factory is. And that's what we are going to do. So this is just a good example of that. So I'm very sure you've seen how dynamic the library that we've used so far have been Python libraries. We've used GeoPandas, which is more or less like functions as pandas, but has the capability to handle geospatial data. And also we've seen matplotlib that we use for data visualization. We've seen Cotestly. We've seen Folium, which is used for interactive mapping. And now we want to kind of like add more data add more context to what we already have, which is the local government boundary, and then see how we can leverage other Python libraries to make it better. So we'll go back to our grid tree. We'll check for Earth facility. Check for Earth facilities in Nigeria. So this data contains all Earth facilities in Nigeria. So whenever you are checking data grid tree data, always look at this abbreviation. So if it is Nigeria, it will be NGA. If it is Zambia, it will be ZAN, so that you download the right data. Yes, so we have the data now. So for this data, I'm not going to download the shapefile because I want to show you that I want to show you how we can actually convert a data that contains some geospatial feature, but is not in geospatial data format. So I'm going to download this in CSV. So once you download this in CSV, it's downloading. So I already have it on my laptop, so I'm just going to import that. And we work on it together. So let me put this. Let me get this. So remember that we downloaded a CSV file, not a shape file. We didn't download a GeoJSON file. So the way we are going to interact with it, we are going to interact with it as just a normal data. For example, import pandas as PD. So we're going to be using pd.read_CSV. If this was a shape file, it's going to read .shp. And then instead of read_CSV, it's just going to be .read_file. And instead of PD, it's just going to be GPD. If we are dealing with GeoPandas, it will be import GeoPandas as GPD. And if we're handling shapefile, it will be gpd.read_file, and then the part of the data. So we copy parts, which I always do because I don't want to stress myself. So this is just removing it and then copying what I already have, then putting it, and then I have this, and then I run it. So we have our health facility in CSV format. So it is very important that when you have data that is in CSV format, you can also convert it to a geodata frame, as we always call it. So we have the normal data frame in pandas, and we also have the geodata frame whenever we are dealing with geospatial data. So this is the information about all the health facilities in Nigeria, right to their local government, to their state, to their ward, the name of the facility level. So this gives us a lot of insights. So we have the latitude and we have the longitude. So to convert this Panda data frame into GeoPandas, we already have the latitude and longitude, which is what we actually look forward to when we want to convert a Panda data frame into a geodata frame. So we're going to be using from shapely.geometry and importing points. Then we're going to create a new column, which is called geometry. And then we're going to combine this longitude and latitude. And then create a new, and ensure that the coordinate reference system is 4326, which is what we work with whenever we're working with this data. So we want it to come in that format, in the coordinate reference system of 4326. And when we load it, okay, I think I didn't load some of it. Now we converted a data frame, a Panda data frame, into a GeoPanda data frame. Now we have it. And another function where you want to convert what you already have into for example, so this would be HF, because that's what, so this is a data frame to file. There you have this. To download this, so the head facility will no longer be in CSV again, to be in Shapefile, which is the format. So also to visualize this, it is very simple. Just import folium.map the location, the latitude and the longitude together, and then we have this, which we've already done. So because we have a number of states in Nigeria, we will just, for the sake of this analysis, we'll just focus on one state. And see if we can explore the head facility in that particular state. All right, so this is just to share the information, so to prevent redundant code. So HF is what we've assigned as head facility, and we're going to filter out Bauchi. So we're going to focus on Bauchi for the sake of our analysis. We're going to filter out Bauchi for the sake of our analysis, and then it is taking a number of times. So because our time is far spent, let me just end it. And then we create a new geodata frame that contains only Bauchi's data. So take, for example, this contains all the head facilities in Bauchi compared to the data that we're working with that contains all the head facilities in Nigeria. But this, we filtered it to contain just all the head facilities in Bauchi. All right, so that's for head facility. So let me comment this. As you are aware, the same way we filtered out Bauchi from the head facility data, we also want to filter out Bauchi from the local government boundary data, because we don't want all the boundary data of Nigeria to show. We want to filter out all the head facility data from in Bauchi state, and also want to filter out the local government boundary for just Bauchi state. Filter out Bauchi boundary data, local government area boundary data. So all this is just basic Panda featuring code. GDF, let me scroll up to avoid confusion. So GDF is the variable that we assign for all administrative local government boundaries in Nigeria. And that's what we are featuring out. So we are featuring out in the data if the state name is Bauchi. So this is it. So we filtered out for Bauchi for the health facility, and we filtered out for the local government boundary data. And also to do a quick visualization of it, you can use contextually to see the distribution of health facilities in Bauchi within the administrative boundary layer of the same Bauchi. So now we can see, using contextually, we can see the distribution of all health facilities in Bauchi State. You can see the distribution of all health facilities in Bauchi State within the administrative boundary layer of Bauchi. There are some that intersect, and then we are still going to do a proper visualization of this to see the data better. But this shows that you can actually visualize, you can actually combine two different data, the administrative boundary data that contains geospatial information, geospatial boundary layer of different states, and then you can take a data that contains all the health facilities and find a way to join them together, which is what we are going to do next, to create a new data set. And we're going to call that data set facilities. So to do this, we're going to use S-join. So S-join is a function that is used, especially in spatial data analysis, where you want to join one or two data together. So each of them is going to have some form of something in common. And what is in common for this is actually because it is Bauchi. So the one on the left is the health facility that contains points. So hospitals are represented in points, while in Bauchi, GDF, which contains the administrative boundary layers of Bauchi, are in polygons. So that's why you have a lot of polygons. So this Bauchi.gdf, the data is these polygons, and then this Bauchi health GDF are all these points. I want to merge them together to form a new data frame, which we are going to call facilities. And to do this, we are going to use the GeoPandas function of spatial join. We're going to join them together. And then inner just shows the way we're going to join them together. Is going to be inner. The two columns are going to merge on a particular point. And then now, this shows that we merged two separate data together. We've merged two separate data together. So whenever we call facilities also contain the points of each head facility within a particular local government in Bauchi data frame that we have that has the boundary layers. And also we're going to import Folium so that we'll have a very good visualization of our data. So, and another interesting thing about working with Python libraries is that, for example, you can change your base maps. So base maps are more or less like open source platforms that provides free base maps. So this is from CatoDB, and the one we saw earlier when we used Folium is OpenStreetMap that shows kind of like very interesting visualization. So these are the options that you have as when you use Python for your spatial data analysis. You get a lot. You get so much done in terms of you understanding your data and exploring it. So when you click on this, you can actually get the primary, the local government, the name of the local government, and then the facility level. So this is Ndubu primary health clinic. Let's check this. Let's check this. Bantu health clinic. All right. So my time is fast spent, and I would really love us to. I just hope that we learned so much. At least this is more or less like an introduction to using Python libraries for spatial data analysis. Even though this is just basic exploration of our data, we've not done any. We've not explored key techniques of spatial analysis, and this is because of our time. And I just hope that in subsequent webinars we'll be able to explore that. So this is just to check out another form of visualization that we can use. So let me just run through the code. So this center just means that the code is just going to get an average of each of the latitude and longitude, so that the first display that you see on the map will be the center of where your map is going to show. So rather than showing the whole of Nigeria, it's going to show the average of the geometry of that particular location. And then you're going to map it. Zoom start is kind of like the zone. The tiles is more or less like the base map. So you can change it to CatoDB. It's going to change the styling of what you already have. So the one up is CatoDB. It's just the star. And then this one is OpenStreetMap. So this code is that, okay, for every row that is in facilities, you ensure that the location of the markers represents the latitude and the longitude. And when you click on the pop-up, it should show the facility name, the facility level, the ownership, and the local government. And this icon is just a basic visualization that we're going to see. I think it's because it's loading, it's still loading. So you can see a lot of visualization, and then you can actually zoom in. You can zoom in to each street. You can know, okay, this is Sambua Carrier Primary Health Care Center. You can, so a lot of analysis that can go forward from this, but because of our time, we won't be able to. For example, you want to know, okay, this means that Bankawa covers this area. So you want to know, you want to put a number to the coverage to see, okay, can Bankawa actually provide health facility? Will Bankawa be enough to provide health facility to the population around here? So there are a lot of questions that we can ask to analyze to get insight from this data. So this shows the basic display and visualization of primary health centers, health facilities in Bauchi. So this is only in Bauchi State. And Python libraries are a very good tool for if you want an exploratory analysis of your data. I will highly recommend that you pick it up as a skill. Even though you are getting better in your QGIS learning and practice, it's also important that you consider and you pick up Python skills, especially in geospatial data analysis. So you can see when you zoom in, it forms a cluster. So you can actually make a kind of like a quick glance of the cluster of health facilities that are available in a particular area. So for this, you can see the polygon that shows where it covers. For this, you can see that we only have Balma Health Post Primary and Balma Primary Health Center in this particular location. I hope that in our next class we'll be able to do some very interesting analysis, which I'm very sure. And I hope that this class has kind of like increased your interest to pick up this Python geospatial analysis skill, to learn it, and this will actually help your goal to become a fantastic geospatial professional. So I hope that in our next class, if the community gives me the opportunity again, we'll be able to explore deeper analysis like buffer analysis, nearest neighbors, coverage analysis. And I hope that if you go back to this recording, you'll be able to learn to just do a general exploration of your data using Python libraries. Thank you so much, and I hope that you've picked up a number of stuff in this class. Thank you.
Thank you, Godwin. Thank you so much. And just like I've said, that if you have questions, you can always drop it on our group, on the group. If you have not joined the geospatial group, because I would just advise that whatever questions you have, you drop it on the geospatial group and not on the general group, because in the geospatial group, we are not so much there. I mean, not that so much, but messages are not so much, so you can easily be attended to. So whatever you have, whatever question you have regarding this class, you can drop it there. So of course, one or two persons will attend to it, and we can even easily forward it to our today's facilitator. All right, so I don't know. I will put out a poll probably early next week to know our interest, and the poll will be on the geospatial group to know our interest if we are going to continue particular, maybe do a part 2 or second week for this. So I'm going to take our interest on that next week, Monday. All right. So of course, if you can literally type it today, even before the poll, if you really want the second, if you want to really continue the learning on this, or you want to go and learn on your own. So then there are still other amazing class coming up in line with this, and I join you. This is a recorded class, just like we have been told, and then we're going to work around it and see that it's posted lately by Monday on our YouTube channel. Please like, follow, and so that you can receive more of our good content and educative content to help your learnings. Thank you once again for having us, and it's a great privilege to have you around. See you next time, and then have a great day. Have a great weekend. Enjoy your weekend. Bye.
Yeah, excuse me, Blessing. Hello, Blessing.